Hello everyone. Today I'm back with another video on Windows sequence, their generation using their generation and showing it with the help of GUI. So let me explain what GUI is. GUI is graphical user interface which helps us to uh, create apps. We create apps directly using drag and drop mechanism. Here, our main aim for today's experiment is to write a MATLAB program to generate a discrete time sequence of windows, that is Windows functions, and to obtain magnitude spectrum. Here, I have used like 5 different windows. Those windows are triangular window, Hanning window, Hamming window, and Blackman window, and the default window as rectangular window. And apart from this, I have my two functions, which is the DTFT function and calculate function. So let me first explain what DTFT function is. DTFT function is nothing but finding this is a function which finds discrete time Fourier transform. So as you know, the as you know what as you know the formula of discrete time Fourier transform. As per the formula, I have written the code. Here, x is the length of the x is a variable which is an array of length w. Now n is the length of x, and my n changes from 0 to n minus 1 in steps of 1. WKR is kind of fiddle factor, and here is my code for finding the DTFT sequence. Here I have used my matrix method so that I have eliminated the use of additional for loop, and it is better to use matrix method because MATLAB itself supports is strong with matrix multiplications. So this is my code for DTFT sequence of any window function. So whatever window function we call, it comes as x into this function, and we get the DTFT sequence of this function. And the other function is like calculate. The calculate function here calculates my main lobe width, the transition bandwidth, so stop band attenuation, main lobe height, and side lobe height. So first let me explain what these terms are. So in order to explain, let me first run my GUI. Here I have my GUI. Here I am selecting my window length to be like around 21, and I'm just selecting a triangular window and searching for result. So this is my discrete time sequence of a triangular window, and our first objective is completed. Our second objective is to find the main lobe width, transition bandwidth, stop band attenuation, stop side band, and let me explain these terms to you. Main lobe width. Main lobe width is the width from the peak point till the first what is it? Minima. Transition bandwidth is the suppose we have our minus 3 dB bandwidth here. So the transition bandwidth is the bandwidth from here to the local minimum, and stop band attenuation is the ratio of second local maxima by global maxima into 100. And this is the side lobe height. This is the side lobe height, that is approximately minus 13, and main lobe height is approximately 46. This is my window length, and this is my triangular function. Let me increase the window length and see what happens to the main lobe and all this. Let's see what happens to all these values. Just taking it to 51 and searching for results. As you can see, the main lobe width has decreased. Let me just compare. Our previous result was 0.63. After increasing the length of the window, the main lobe width has decreased. Transition bandwidth decreased. Side lobe height increased, and main lobe height also increased. So this is the relationship between window size and the all these factors. So let me explain how I have created this GUI. Creation of GUI is very simple. You need to just go and type guide in command window, and here we get a pop-up guide quick start. We can create a new guide. So I started with my new guide, but let me open the existing GUI. Here is my existing GUI. This is my access 1, this is my access 2, and these all are my push but what is uh, space to show my reading. So let me explain the GUI code. When you put this layout, there is an auto-generated code in which we are auto can generate a code of this layout. But in order for us to work with this, we need to code for this button. When we push the button result, we need to trigger some part of our code. So let me show you what the code where I have written. Okay. So selecting guide, let me go to the view callbacks, and so initially this all this is created, but this part of the code is what we have written till here. So let me go through this code. So here L stands for, first of all, we are my first window. What do you say? This window. The window, this window, like everything present in here is termed with handles dot, and this is my edit one. So I'll enter something in here, and we'll get it to length L. So most probably we'll be entering a number. So if at all, so we are considering it as string. So that's why we're using get, because we're taking it as a string and then converting to string to double. So next is my like window number. This is something about its value. So I'm just taking the value of the window number from the pop-up menu. So this is my pop-up menu. From this pop-up menu, I'll take the value. So if I'm leaving it like this, then I am having rectangular window. If I'm so, or else when you go through this, we'll get when you select other parts, we'll get numbers accordingly. So if we select 2, then we get triangular window. If you select 3, we get hand window, and etc. So by default, we are setting it to rectangular function. Excuse me. So from length of the window, we get the value of m, which is as we know that L is like the tabs. If we say 25 tab window, then L is 25 and m is equal to 12. So we go from minus 12 to 12 and get the discrete time sequence, and these are the codes for triangular window, panning window, and etc. We have used the matrix multiplication form. So now we need to calculate the magnitude response of DTFT of these in any of the selected window. So this is my selected window coefficient. It might be this or anything. We are calling the DTFT function as we discussed here, and then we are taking the mod. So that's what this whole part is my magnitude response, and of that, for that we are applying the converting into decibel. So this is what our graph looks like. Let me show you. Oh, sorry. So let me run the code for you once again. So this is my Hamming window. I'm just putting some result 21. This is my favorite number. So this is my discrete time sequence, which can be plotted here, and this is my what do you say? Sorry, axis. This is my this magnitude response of the Hamming window, and this is my actual Hamming window. So in axis 2 we are just plotting the magnitude. In axis 1 we are just plotting the actual in actual one we are just plotting the actual this. So let me. So after that, now our main important function is to calculate all these terms. That is main lobe width, transient bandwidth, etc. All these terms. So we call the calculate function, and in this calculate function, let me explain how I calculated it. Here this sentence gives me an array of local minima. Tops give me the array of local maximums, and maximum which main lobe width is equal to a minimum of W of ranges, and pass band is equal to minimum of W of window DTFT, which is less than like uh, till less than minus 3, and stop band attenuation, as I have discussed, maximum of window DTFT minus stops of 1, transient bandwidth, like what is main lobe width minus pass band. So and main lobe is the maximum value, and side lobe is the first local maximum. Then there is second local maximum. And so let me again run the code for you. So for now I'm selecting my window into this, and it will go with some black man, and here's my result. So this is my black man window. This is its magnitude response. So this is my main lobe width. So main lobe width is from this point to here. This is my main lobe width, and from minus 3 dB to here. This is my transient width. Next, stop band attenuation is this peak by this peak into 100. Side lobe height is approximately 178, and main lobe height is approximately 38. So here, creating a GUI for this window sequence is an effective way of comparing which window is better for different lengths. So I would like to conclude my experiment with this video. Thank you everyone.